However, when man himself set out to build an electronic brain and to construct goal striving mechanisms of his own, he had to discover and utilize certain basic principles. Having discovered them, these scientists began to ask themselves, could this be the way that the human brain worked also? Could it be that in making man, our Creator had provided us with a servo mechanism more marvelous and wonderful than any computer or guidance system ever dreamed of by man, but operating according to the same basic principles? Maxwell Maltz. I'm currently reading a book called Psycho Cybernetics by Maxwell Maltz. And I came across this passage and I thought that it would be fitting for this orientation presentation. I've struggled a little bit with finding the right way to approach learning artificial intelligence. And I think that a lot of you are struggling with that also. And so I thought maybe this particular passage would be a good way to start with the framing of what we're attempting to do. We're going to talk about the natural intelligence. Okay? This is the blueprint for AI. And I named this course this way because before we talk about machine learning, AI agents, or models, we're going to slow down and look at something far more powerful. And that's the human mind. We're going to attempt to do something most technical education skips entirely. We're not going to start with code, and we're not starting with the operating system of our machines or our laptops or our desktops. We're instead going to start with the operating system that all learning depends on. And that's how information moves through the human brain. Now, before we get started, I want you to ask yourself this question: why? Why do you want to learn AI? Why are you taking courses? Why are you signing up for tutorials? Why are you doom scrolling on social media about different AI generated content? Why? Is it rooted in fear? Is it from anxiety? Are you excited about the future? Are you curious? Whatever it may be, I need you to know your why before you start taking this course. Now, what you're looking at on the screen right now is the roadmap for this course. And you can think of it as a systems diagram. It's not technically a syllabus, but it will give us structure and a flow by which we'll learn the material. By the end of this course, you won't just recognize these components, you'll understand how they constrain everything you try to learn or build. Now, at the very top, you'll see a shared flow underneath the human information processing. You'll see input, process, and storage. Now, this is the core architecture for both human cognition and artificial systems. Everything in this course lives inside of that flow, that input, process, and storage. What are our learning objectives? Well, the first one will be to reverse engineer the source code. During this objective, I'm going to map what I call the Magnificent Seven. These are biological learning axioms that are directly counterparts to artificial intelligence. This is aimed to bridge the gap between human cognition and AI architectures. Architectures like transformers, RAG, and other techniques like fine tuning and inference. Then we'll navigate hardware bottlenecks. The objective here is to identify and mitigate the strict biological constraints of the human brain. Every brain is created differently, and the host of the brain also plays a major factor in how that brain develops. Three, we'll talk about the architect or architecting, excuse me, will architect the knowledge graph. Now, here we're going to master the construction of mental and digital schemas. If you don't know what a schema is, don't worry. You'll learn what that means and how it applies to human and artificial systems. Next, we'll execute a track specific prototype. And this particular objective will be to successfully deploy either a high salient strategic blueprint, this will be for my architects, or we'll build a Python based technical agent for my technical builders. We'll talk about a minute here about the different tracks that I have. And then finally, we will construct the neural twin. And this neural twin is going to synthesize the entire roadmap into a final capstone project. Now, first thing that you'll need to do is choose your track. The first track is the architect track. This is designed for educators, leaders, and designers. Your goal is to master the requirements of learning. The builder track, this is more for my engineers and my developers. And this is where we will focus primarily on implementation, deployment. How do we actually manifest and create products and apps using this new technology? You'll be using Python based agents, Jupyter notebooks, and you'll work with RAG prototypes. Now, let's talk a little bit about each of the subtopics that we'll discuss in the course. We're going to begin with the source code. This is where we zoom out and establish the full system. And again, this is where I'm going to introduce you to the Magnificent Seven, as I'm calling it. Right? I've coined that term, not the Magnificent Seven tech companies, but these are going to be the seven axioms that govern how humans actually learn. These are not study tips, they're more constraints, biological limits that no amount of motivation can override. Next, we'll move to the gatekeeper. The brain does not process everything it receives. In fact, it ignores most of it. Attention is a filter, it's not a spotlight that you control at will. Here in this section, we're going to bridge human salience to prompt engineering. Again, creating a bridge between the human and the artificial. We'll learn how to open this gate intentionally. Now, the bottleneck or working memory, once information gets in, it's hard to uh, move past certain limits. If you know anything about memory, whether it's artificial or human, Our memories are somewhat narrow and fragile. We get overloaded very easily. Just think about when it comes to learning about AI. Every time you try to learn a new technique, learn a new model, learn a new way of processing data within that model, it changes. A new model gets released, you have to learn something new again, and everything you've learned or everything that you remembered is no longer applicable. So, during this subtopic, we're going to focus on the cognitive load and why humans can only process about four meaningful chunks of information at a time. And I'll connect this directly to context windows and token limits in AI systems, just so that we have a bridge for capacity constraints. Parallel processing or dual channel. This is where we'll talk about bandwidth. Humans process visual and verbal information through separate channels. You ever try to listen and watch two different people or two different sources of data? They don't work so well when they're in competition, but when they work together, our learning accelerates. So we'll talk about this parallel processing as it pertains to learning in a multimodal context, similarly to the way our large language models are able to produce text, video, images, or even audio. Now, with the knowledge graph or schemas, we'll move into storage. The brain does not store isolated facts, it's going to build networks, this knowledge graph or schema, which is essentially a cluster of meaning. During this subtopic, we'll connect human schema formation to vector embeddings in AI systems. Next, we'll talk about the compression algorithm or active processing. Now, learning does not happen when information goes in. Right? The more information we take in does not equate to actual learning. It actually happens when we learn, it actually happens when we output or when we retrieve. So we'll talk about how to activate this processing and then also how it connects to error driven or evaluation learning in AI systems. Then we'll talk about the query function or retrieval. This again also relates to the strengthening or the hardening of learning throughout the retrieval process. Pulling information out of memory doesn't just reveal what you know, it changes the memory itself. We'll map this to inference in AI systems because a model that never runs inference is in fact useless. And finally, we'll deal with permanence. Without reinforcement, both biological and artificial systems forget. We'll cover spaced repetition, consolidation, and reinforcement. Then we'll bridge it to fine tuning and weight optimization while being explicit about where that analogy ends between humans and AI systems. Technically, humans, we don't update weights like a model does, but both systems do require repeated structured exposure to stabilize and harden the learning. Now, finally, we'll walk through or go through the capstone project. This will be a neural twin. And depending on your track, whether you're more of the architect or more of a builder, you're going to design a learning architecture for a human learner or build an AI agent that respects human cognitive constraints. So that's our course roadmap. And this will conclude our orientation for today. Now, this course exists because most people try to learn AI without understanding learning itself. I myself have encountered this problem, and I thought, why not focus on something that's a little bit more stable and consistent, which is our ability to learn. This, in fact, is a skill that will see us through whatever AI is going to change in our ever changing environment and landscape. No matter what happens, we will continually have to learn. So why not start there? Now, by the time you finish this roadmap, you won't be just prepared for the next courses I'll be presenting, but you'll have a systems level understanding of how our minds work and then how to relate that to artificial minds. So, thank you for your time. I look forward to presenting this course to you, and I will see you all next class. Happy New Year.